Okay, so right now we are going to discuss numerical examples about the parameters, and we are going to start with CMRR, which stands for Common Mode Rejection Ratio. You know very well the purpose of understanding parameters is to make sure that how to know which op-amp is good and what characteristics decide a good op-amp. So as far as numerical is concerned, the first question is there on the screen. I give you AOL or open loop gain or differential gain and ACM or common gain. And the purpose was to find out CMRR. And this is very simple. Now how you will do this equals to A open loop, already it is there 100,000 divided by 0.2. If you solve this, you're going to get 500,000. But most of the time, you're not going to get the CMRR simple in your books or in the shops of if you're going to buy. So what is the purpose? What is the reason for that is our OPAMP CMRR value is very, very high. For example, if you are going to buy a land whose area is 100,000 square centimeters. Is it making sense? It is okay. It is making sense, but it's a very big number, right? Why it is being big numbers? 10 or 100,000 centimeters itself is a very big number. So if someone will tell, okay, how much is the area? 100 square kilometers. That is okay. 50 square kilometer. That is fine. So whenever your values are big, the unit we are looking for is big, so that number is reasonable. Same is the case with CMRR. Normally its value is in million and billion, so directly writing this value is a very big number. It is not very presentable. So the alternative is logarithmic value. And you know, by logarithmic, you can convert a very big number to a small number. Let us see the answer of the same question in decibel. So we have a formula is on the screen that will tell you the CMRI in decibel that is here. So what is the way to write equals to 20 log 500,000. Simply use your calculator and you will find it somewhere around 114 dB. dB stands for decibel. So this is the way you can calculate your CMRR. I hope it is making sense, right? Now, if I will say that, let me give another simple question because most of the time you will get a question like this in the exam. So, okay. Now the question is, okay, I'll choose another color so that it will be dark. A open loop is equals to 1 million and a common is 0.1. In this case, if I will ask you what is the value of CMRR in dB, very quick answer from someone because already we have solved this, so you know how to solve. Can someone tell me how much will be the answer? Equals to 20 log 1 million divided by 0.1 means it will be 10 million or 7 zeros. Correct, yes, correct, Mohammed Hamid. 4, 5, 6, 7. So how much will be this value? I think this will be 140 dB. Correct? Good. Yes, yes, Alhamdulillah, everybody understands this. So that's all regarding CMRR. Fine. Now let us go to the next slide. Input offset currents. We already have discussed this, that whenever we are going to start an OPAMP, what we expect is that when there is no input, how much output will be good? Anybody is having any idea? Okay, Mohammed Salman, fine. Yes, yes, yes. Listen, I gave you example of a weighing machine. Weighing machine is to make sure that what is the exact weight. If you are buying a grocery, some errors you can afford. But if you're going to buy gold or dahab, even a gram will cost you 200 to 300 riyal, right? So what you want, that whenever there is nothing on your weighing machine, your output should be zero. But it doesn't happen. So most of the machines have got a reset value, and the reset value is to make sure that when you press this, the net weight is zero, even if you've got something on the weighing machine. You got my point? For example, if you're using to buy a bucket and that is made of metal, so its weight is a bit heavy. So you cannot include this with the weight of the grocery, because then it will be zulm. You can. It's not the weight of the grocery. So what do? You make sure that before putting actual things, the weighing machine shows zero. The same with OPAMP. A perfect OPAMP should have output zero, which is not the case, because you know very well that if we have got an amplifier, uh, this operation amplifier need DC voltages to work as an amplifier, and these DC voltages gives some output even if there is no external input available. You're getting my point? So to cancel this, what we do, we apply some input voltage in such a way that it will cancel the effect, and the result after applying this input voltage will be zero. This is what is input offset. Uh, you got my point?
Doctor, please can you again for this?
Okay. So, so what I'm telling is input offset is a DC voltage applied to the operation amplifier, and the purpose of applying this voltage is to get the output zero. But what is the purpose? Actually, your diode, your op-amp output should be zero when there is no input. Theoretically it is correct, but actually we have got something in the output, and I told you the reason. The reason is that because of the DC voltage you apply to the op-amp for biasing, results some output. So if you are going to apply some input before that, these outputs should be compensated so that finally your output is zero. So how you will do this? You will apply some input in such a way, depending on polarity, positive, negative, that the final output after applying this input voltages will be zero, and this is what is offset. I want someone to translate this in Arabic for me, if anyone understood this, what I'm telling, because this is an important concept. Anybody is there? Yes, all of you got my point. This is bit, it's not confusing, but it is a bit lengthy. So I want you people to discuss among yourself right now, so that if somebody is having some confusion, he can discuss. Yes.
Sure.
You got my point. Yes, I offset voltage.
I want to ask you. You mean by that the output is in ideal way it has to be zero, right? But
No. Yes.
practical that when you put a DC voltage to the current input, تمام, it will have some output range small output. So you want the new voltage to compensate with the output, right?
Yeah, very much, very much. But how we are getting this voltage? We are not actually applying some input and we are getting something in the output. Because of the DC voltage is present in the circuit, even if there will be no input, there will be something in the output because of these effects, small leakages and all. You got my point?
No, wallah, I didn't understand.
Yeah, I know it is a bit tricky. Once again, I'm repeating. All of you sincerely listen to me. If you are playing PUBG or whatever, just stop for some time. What I'm
No, no,
telling
with
is,
you, with you.
okay. So what I'm telling is, electronic devices are very sensitive. Even if you will not apply anything in the input, noise itself will behave as if an input is there and you are going to get something in the output, right?
How is
So,
that?
because listen, if you have got a circuit, any circuit, electronic circuits, it needs DC to work, right? And DC voltage itself are in millivolts. If this DC voltage is there in the circuit, somewhere its effect will be there in the input, and this input, which is multiplied by a very big value in the amplifier, becomes a value in the output. So what it means, even if you are not applying any special inputs, but because of this DC voltages, you are going to get some output. I will show you how an OPAMP works. Give me a time. I will exit from this slide and show you the first chapter slide. Then maybe you will remember. So can you see my screen?
Yes, yes, Dixon.
Yes. In this screen, can you say these are the minimum things you need? Okay. What are the minimum things? You have got two inputs, one output, and two voltages. Okay. Now these two voltages, what they are called, anybody knows? They are called as biasing voltages. And
Doctor, we cannot hear you. Yes, doctor. Hello?
is it okay now? Can you hear me?
Yes, yes.
There was
Doctor,
something wrong.
you mean
Yeah.
you mean by balancing the turn on and off?
Yeah. You remember transistor can be used in three regions: cutoff, active, and saturation. When both
Mm,
junctions are followed bias, it is called saturation or on. When both junctions are reverse bias, it is called as cutoff or off, right? So how you can achieve this? How you can achieve this by applying these two voltages?
Okay, you mean by voltages to turn on and off, right? So
Yes,
if
yes.
there is voltages but there is no input, there is might be some leak by that mean, right?
Yes.
Yeah.
Fine. Listen. For example, if you see the radio, in the radio you need to put a battery, then it will work, right?
Yes, yes, doctor. Right.
And but this is not the input. The input is electromagnetic waves that antenna will receive, sir. So when we say about input, we don't assume battery or these VCC and V. These are like a shart needed so that your op-amp will work. But what happens even if these two inputs are grounded? What is the meaning of grounded? Nothing in the inputs, huh? What you will see that ideally there should be no output, but there will be some output maybe in microvolt. How we get this? Because of the presence of these two voltages. But if you want something perfect, not in micro, rather it should be in millivolt. So if you want a perfect output, what you will want, you apply such an input so that gabal khamsa milli, a sort of input you will apply nagas khamsa milli. So kam kamil natija, kamil sifar. So this nagas khamsa milli you apply is called as input offset voltage. Is it making sense? Listen, all of you, I know I can skip and you will not feel something big is missing, but I want you to understand these basic things because amplifier is everything for you. You need to be very good.
Yes, yes. Now more sense, doctor. Now more sense. Yes.
Okay. Can you explain, yes, Saeed, the purpose of this and why we apply and what is the faida of applying offset voltage to your friends in Arabic?
Yes, yes.
Aywa, faddal.
Yes, no problem. Okay. Okay, a second, please.
Okay.
اوكي دكتور. يا شباب الاوفست يقصد فيه انه الفولتج البلس والماينس فائدتهم انك تسوي تورن اون وتورن اوف، لكن بعض الاحيان يوم تسوي تورن اوف ما يكون في انبوت يصير في اوتبوت بسيط، يعني يصير في تسريب للفولتجات. الاوفست فائدته انه ما يصير في تسريب للفولتجات، بحيث انه ايش، مثلا انت تبغى 10 فولتج لكن يصير اصلا في تسريب 3 فولتج، فالاوفست راح يعطيك السبعه، ما راح يعطيك 10 يصير 13، يصير يوازن بين الفولتجات وبين التسريب اللي يصير. اوكي ثانك يو دكتور.
Yeah, all of you, is it okay now? I hope your friend has done a great job and now it is more clear, right? Jazakallah khair, a clap for Mr. Saeed. Yeah, all of you. Why
No problem, doctor, no problem.
Okay, fine. So anyway, now it is clear. Now I will again unshare my screen and go to the chapter 2 because it is chapter 1. Aywa, Jazakallah khair ya Fahad. You are a gentleman. As I was telling, this subject is actually very easy. So we have to do some research. So now it is clear, right? Input offset bias is average, right? You know what is average? Just add and offset in current. And what we just talked was about voltage. About current, it is only difference. Okay. difference in input impedance. I don't think there is something else which is important other than slew rate. Anybody can explain me other than Saeed, what do you mean by slew rate? Because we had a discussion on this yesterday. Not last topic yesterday we had, right? Can someone tell me what is this and what is the purpose? Yeah, all of you, where you are. I want anybody other than Saeed to tell me what is slew rate. Not just read the what is on the slide, but what do you understand actually, or you if you want to add something to what is there on the slide. Fine, fine. Listen to me. You know what? For our electronic devices, frequency is a very important factor. And whenever we have got some device, we used to analyze how it responds to different frequencies. So what will happen to a range of frequencies? It will behave good, and for remaining, it may not. So the range of frequencies where it performs good become its bandwidth. You got my point? What I'm telling? Let me be a bit more clear. I will zoom this and I will. You know what is frequency, right? You know your frequency starts from 0 Hz and it goes up to megahertz and gigahertz, right? Let us assume here it is kilohertz, hada mega, yamin mumkin hada giga. I'm just trying for your reference. Now what happens whenever you are going to design a device? What you will do, you will analyze its frequency behavior. Why? It is not possible to design a device which will perform perfectly fine for any frequencies. It is not possible because all our electronic devices, they are limited by frequencies. Sometimes they do good. So let us assume that its frequency response is this. What is the meaning of this? दाखिल this daira, your natija wala khasais of device is good. Lekin gabal wala isar, it's not good. One of yamin, it is not good. So if anybody will ask you what is the bandwidth of, let us assume this is 1 kilo, this is 1 mega. Can you see the screen, all of you? So my question is, you have got a device and this is the frequency response that is there on the screen on the right side. This is frequency response. The frequency response is good from wahat kilo il wahat mega. If I will ask you how much is the bandwidth, who will tell me? Okay, 1 mega. Your answer is approximately correct. But if I will ask you that I want 100% accuracy, then do you have something to add to this? Yes, Said. Your answer is no, 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 no. You didn't understand. Fine, fine. You are approximately correct. I will tell you the answer, but what I'm looking for is not this value. Anybody else has some different answer? Yeah, all of you, you understand my point. You know what is bandwidth, right? Bandwidth is the range of frequencies any device is having or performing well or like that. Now you have got a device whose frequency response is there on the screen. What do you mean by this? The green area is the area where your OPAMP does amazing good and not before that, wala not beyond that. Wala mafi gabal wahat kilo, wala mafi baad 1 mega. So how much is the bandwidth? Simple thing is, we have got a law for bandwidth. What is that law? Bandwidth equals to FH minus FL. You know what is the meaning of H and L? Highest frequency in August, lowest frequency. What is the highest frequency in this rasam, Yamin? What is the highest value of the frequency you can see in on the screen? Very good, 1 mega. Minus, what is the lowest frequency? 1 kilo. Now, how much is the of 1 mega minus 1 kilo? Who will tell me the answer? Okay. Listen, these are different numbers, right? 1 mega and 1 kilo, they are not different. I'm talking you to minus. Yes. We have got a smart guy. So I'm repeating. Listen, 1 mega and 1 kilo, they are in different scale, right? And you cannot make minus like this. You have to be smart. Either convert mega to kilo or kilo to mega. I will convert this into a mega. Khali wahad mega. Nagas. 1 kilo we can say 0.001 mega. Yes or no? If you have got in kilo, you want to convert in mega, then you have to divide, right? So 1 nagas, so it will be 0.999 mega. Takriban wahad kilo. Said your answer was not wrong, but in this kind of questions you have to be accurate. Okay. Yeah, all of you got my point or no? Okay, fine. So this is another question, sometimes not clear. Muhammad Salman, I want someone else to explain. I will tell you, no problem. I gave you a question, and question is here on the screen. No, Fahad, it's not like that. Listen to me. You also listen to me here. Again, I'm telling. We have got a question. We have got a graph of frequency response of a device. What it says, your device does good in this range of frequencies, right? Can you see the green shaded region? In the green shaded region, where it's it start at 1 kilo and it's end at 1 mega. What is the meaning of this? This device only work when your frequency is between 1 kilo to 1 mega, right? Now the question is, how much is the bandwidth? And you know there is a law for bandwidth. What is the bandwidth? Bandwidth is the difference of highest frequency to lowest frequency. Highest frequency is 1 mega and lowest frequency is 1 kilo. So very simple to calculate the bandwidth. I wrote law. Then I wrote 1 mega and minus 1 kilo. Now we cannot differentiate immediately because these two are not the same values. So either you have to convert mega into kilo or vice versa. Mega is a good number, so I prefer mega. So I have kept 1 mega like this. But wahad kilo I changed to 1 mega. To mega it will be. How you convert? If you got in kilo, you want to change it to mega to divide by 1000. I divided and it was 0.001. So 1 minus 0.001 will be 0.999. What will be the unit? Because this is what is the one you have used. So finally, this is the answer, that your bandwidth will be 0.999 mega. Fine. You're getting my point? Yeah, all of you listen. I think we have to stop here. Let us. What is low? What is the low? Low is listen. This is your